Hello everyone, welcome to Sweetie Speaks official YouTube channel. We are in System Verilog OOPS series where we are learning System Verilog OOPS concept. I hope you are understanding this OOPS concept because I am trying to make it as easy as possible and I am trying to cover all concept in sequence starting from basics because we want to clarify all the basic concepts first. Only then we can move to advanced OOPS. If you have not gone through previous video lectures in System Verilog OOP series, please go through because this is a structured approach. If you don't understand the previous concepts, you are not going to understand the concepts which are coming further. Today we are going to see the concept of object deallocation. Let's understand the meaning first. As the name suggests, it's object deallocation. Deallocation means you are deallocating it from somewhere. From where exactly? The object is stored in memory, so you will deallocate it from the memory. That is object deallocation. Let's understand about this concept in detail now. First, we will understand what is object deallocation. It is mainly process of freeing the memory space for objects which are no longer referenced. I will tell you in a bit. You can simply put it in your mind. If you don't require any object in future, why do you want to waste your memory space? It's better to free the memory space. That process of freeing the memory space from the objects which are not required is called as object deallocation. You are deallocating the object from the memory. Simple words. How is object deallocation done? In System Verilog, object deallocation is done with the help of process known as garbage collection. What is garbage? Garbage is something which is unwanted. If the object is no longer required, it becomes garbage. Garbage collection done. How do you know which objects are not required so that you can deallocate it from the memory? Every object will have a handle pointing to it. If there is no handle which is pointing to the object, all the handles which were pointing to the object are now removed. It is no longer pointing to the object. Then that particular object is no longer referenced because the object is referenced with the help of handle. If there is no handle pointing to the object, it means the object is no longer referenced and it will not be required in future. So you can remove that particular object from memory. Now, there is a possibility that one object has multiple handles. We have seen that in the previous lecture. What will you do when the object has multiple handles? In this case, take a simple example. One object was having two handles. Now, one handle is removed, but one handle is still existing. Since one handle is still existing, it means the object is still referenced by at least one handle. So, it is not garbage. When the final handle, which is the last handle which was referring to the object, is also no longer referencing the object, even the last handle for the object is removed. First one handle was removed, now the second handle is also removed. It means in the current situation the object is no longer referenced. There is not even a single handle which is pointing to your object. In that case, the System Verilog will release the memory for it. So finally, object can have multiple handles, but it becomes garbage only when there is not even a single handle. No handle is pointing to that object. Only then it will become garbage and it will be deallocated from the memory. Why do we need object deallocation? Why should I even go through this process of garbage collection? Why? We will understand this with the help of scenario. Now consider your test bench is creating thousands of random transactions. Once a particular transaction is completed and the output is analyzed, that particular transaction object is no longer needed because you have already completed whatever you want to do with the transaction. That process is already completed and it will not be required in future. So then that if you still keep, if you still retain that object in the memory, then what will happen? Simulation time will increase because you are unnecessarily collecting more information in the test bench, which is not even required now. So first thing is simulation time will increase, and memory space will also not be utilized efficiently, because you are keeping things in memory which are not even required. That's why we do object deallocation, to utilize your memory space efficiently and to reduce the simulation time. Now let us understand object deallocation with the help of simple code. I have a transaction T. This is a handle. I am creating a handle for the class transaction. I have a class transaction and I am creating a handle T for that. Now when you say T equal to new, this this handle, object handle T, will be assigned a transaction object. So first object is being assigned to handle T. Now, when you are again doing T equal to new, the second transaction class object is assigned to the handle. When the second class object is assigned, the first class object does not have any handle. This first object will not have any handle and it will be deallocated, because at one time one handle can point to only one object. One handle can't point to multiple objects, only one object. So when you are allocating it a second object, the first object will not have any handle and it will be deallocated from the memory automatically. And for the last object which was assigned, you can use T equal to null, which means you are explicitly deallocating the second object. Now the second object also doesn't have any handle and the second object will also be deallocated from the memory. Now what we will do, we will create a class, we will create the handle, we will allocate the objects, and then we will see how the object is pointing to, the particular class handle is pointing to which object, and we will understand how this object deallocation happens. Now let's execute a proper code. This is the coding example for object deallocation. Let us understand the code. I have a class transaction which has two, two variables. One is 32-bit data and another is 8-bit address. Now, in this transaction class, I am having a custom constructor. Constructor is new. If you have not gone through, there is a lecture on constructor and there is also a lecture on new operator. Please go through it in System Verilog UP series, then you will understand. And it is possible, new is a default constructor, and if you want to customize it, you can do it. In this example, I am customizing my constructor. How? I am taking the inputs for data and address from the user and I am assigning that to the class variables. This is how I am customizing it. So I have a custom constructor to assign values to the variables. Then I have a task to print the values. Now what I am doing, I have a handle to the transaction class T. I am allocating it a object by calling the custom constructor new. Here you can see I have allocated first object and I have assigned values to data and address. Here the first object will get allocated. It means when I call print, these are the values which should get printed. Next, what I am doing, I am allocating the second object to T. When you are allocating the second object, the first object will get deallocated because it doesn't have any handle. Next, when you call T.print, it should print these things, the second object. The first one doesn't have any handle, so only second object. And finally, you will deallocate the second object and then T will point to nothing. If you print, there will be nothing. Now let's run this and we will see the output. First, what should happen? When you are calling it first, you are getting the value of the first object which you have allocated. Then when you are running it again, you will get the value of second object. Now third time what you did, you assigned it to null. So when you are calling print next time, you can see it says null pointer access. Why? Because you have assigned t to null and you are calling print. Now it doesn't have any object at all because second object is also deallocated. That is why you got this null pointer access, because now your handle t is assigned to null. So what happened? First, t is allocated to first object. Then since you allocated t to second object, the first object will get deallocated from the memory. And finally, by calling null, you are explicitly deallocating the second object. That's how object deallocation works. Now what you can do, this I have given you a sample example. By yourself you can create a lot of examples, try multiple handles, multiple objects, try executing it and learn more about object deallocation. I'll see you in the next lecture where we will learn more concepts on system Verilog. Oops. To stay tuned, please subscribe to Sweetie Speaks official YouTube channel. Thank you.